Jodi and Riley are opening a snow cone stand to make some extra money over the summer. To determine the cost they will charge for large snow cones, they took a survey of cost versus the number of people that would buy a snow cone at that price. The data collected is in the table below. Everybody see the data? I scooted this up, sorry about that. Okay, so now, from the pattern in the table, do you think there is a relationship between the cost of the snow cones and the number of people that would purchase the snow cones at that price? Explain your reasoning. So first of all, does there appear to be a relationship? Do you think there's a relationship, yes or no? So for the most part, you guys said yes. Okay, well, if the answer is yes, then I need to know why. Yes? There is a relationship. And why does this need to be in a complete sentence? Because it asks you for one, right? It asks you to explain. Okay? Now, yes, there is a relationship is a great sentence. Okay? But does that explain our reasoning? Okay, so what sentence are we going to use to explain our reasoning? What pattern do you see? As the, can we be a little bit more specific? As the cost goes up by 25 cents, the number of people willing to buy, is that what you said? Willing to buy a snow cone? Okay, a snow cone. What? Decreases by 5. Right? Okay. Is there any way we can adjust this sentence so that it sounds a little clearer and maybe a little bit more towards the correct math vocabulary? There's really only one place that I don't like the words that we chose. Yes, I am talking about goes up. Okay. What can we say instead of goes up? Increases. Very good. Okay. Now, I wanted to give value to your word choice, because goes up, we know what that means, right? But I also want to make sure that we are using our correct vocabulary, so that's why I changed it. Okay? Because did I really change it? Did we really change it? No, it's the same meaning, but we're just choosing a better vocabulary. Okay? Construct a scatter plot of the number of people that would purchase snow cones at the price versus the price of the snow cones. It tells you which one to put where, on which axis, right? The number of people that would purchase versus the price. Where does the price go? On the bottom. Okay? How else could you know? If all it said was construct a scatter plot, would you know that price went on the bottom? Why? Because it's your X's, right? It's on the left side of your table. Very, very good. Okay? Okay, so if price is going down here, how do I want to count each line? $50, $1, $52, $53, $54. That's probably pretty good, right? That's probably a good scale. What are we going to label our y-axis to be? Sorry, number of people, what'd you say, that will buy a snow cone? Okay. And how are we going to scale that axis? By tens? Because we got to get up to 75, right? So 10, 20, 30, 40, 50, 60, 70, 80. That's probably a good scale as well. Okay. Now we just have to plot the points that they gave us, right? So 25 cents is 75. Now 25 cents, remember, is going to have to be halfway in between 0 and 50, correct? So that's 75. 50 cents is 70. 75 cents is 65. Do I need to talk you through this, or you got this? You got it? Okay. I'll just make mine. Check yours against mine. Make sure it's correct, okay? Correct. We're not going to connect it because, first of all we have is a table of data, right? And actually we're specifically calling it a scatter plot, right? Do we always connect our points on a scatter plot? It depends on the situation, right? And in this case, we don't have an equation to go by. Yes, we clearly see a pattern, but we don't want to just randomly connect it just because we see a pattern, okay? Here's something else I want you to think about, and I'm actually going ahead for some questions later, but think about this. Can you have a partial price? Can we have like partial cents? Can we have like 2 cents or 3 cents or 5 cents? We can, right? In this situation, do we? No. Can we have a partial snow cone? Can we have 3 3/4 of a snow cone? To me, that's just like a small snow cone, right? Okay? And so, since we can't have either one of those, since we don't in this situation, what kind of data is this going to be? It is going to be discrete, isn't it? And guess what? If you'll turn your paper over, look at problem number 6. Is it continuous or discrete? Okay, very good question. Did that answer it for you? Okay. All right, so let's go jump up to number 3, back in order. Okay, what are the independent and dependent variables? Independent is which variable, x or y? X. So independent is going to be here, right? Independent. And dependent is going to be here because it's our y value. This is our x. And this is our y, correct? Okay, so independent then for this problem is going to be the cost of the snow cone. Why do they call you a snow cone? Oh, I don't know then. So what's dependent? Okay. Number of people willing to buy. Independent is cost. Dependent is number of people that are willing to buy, or people that would purchase. Okay? Now we changed it to our own words. Is that okay? Because our own words mean the same. Okay? Look at number 4. What is an appropriate domain and range for the problem situation? What is x allowed to be? What's the domain of this problem? Now, this was a problem the other day, so I want to make sure that we are understanding that when we're talking about domain, we're going to use the letter D, because the word domain starts with a D. Okay? So what kind of values are we allowed to have on this problem? Where did our x values start? What's the lowest our x values go? 25 cents. Could it go to 0? Could it? If we had one more space right down here, one more space right up here, if our price was 0, how many think would purchase at that price? 80, right? According to this pattern, it would be 80, right? So could we say 0 is a good starting place? Okay, and how high did it go? Could it go to 4? Then no one would buy it. But could it, because of our predictions, because of our pattern? Okay, so we could say it's from 0 to 4. But we have to be a little bit more specific. Look at our values that we chose. 25 cents, 50 cents, 75 cents. If I get picky, any value between 0 and 4, 176 is between 0 and 4, isn't it? Is it on our table? Is it a possibility? No, because, really, as a snow cone person, like as a snow cone stand owner, are you going to want to have a whole bunch of pennies in your cash register? No. So how are we counting? Counting by 0.25. Okay? Does that make sense to you? Okay. What about my range? Hey, here's a test. What letter are we going to use for range? Oh my gosh, we are going to use R. Why are we going to use R? Very good. Range starts with the letter R. What's our range here? 0 to 80? Uh-oh. I always do that. I always mess that up. That's not an X, that's a Y. Okay. How are we counting between 0 and 80? We can say we're counting by 5s. Could we also say we're counting by 1s? Could I say it has to be an integer? We could, but let's make sure that we're counting by how we're counting in the problem. So counting by 5s. Okay? Okay so far? Is this relation increasing or decreasing? What'd you say? Decreasing? Why do you think it's decreasing? As the price goes up, the number of people go down. That's perfect. That's a perfect way to phrase that. Okay? In fact, the only other way that you can make it more perfect is if the price is increasing, the number of people are decreasing. Okay? So we can say this is decreasing. But I appreciate using what you know and going from there. Okay? Thank you for that. So is this relation a function? Is it a function? Remember last week we talked about the definition of a function. For every x, there's only one value for y. Are any of my x's repeated? If none of my x's are repeated, then they only have one value for each x. So is it a function? Yes, it is a function. If so, what parent function best represents the data? What parent function? Remember that sheet I gave you, the model of parent function sheet? What's the name of this parent function? Yes. It is a linear. Oops, that's not exactly right. Let's just say a linear parent function works best. How about that? Is that a good sentence? Okay. How can you determine the price at which no one would be willing to buy a snow cone according to the table, graph, and algebraic generalization? Let's start with the first one. Let's start with the table. How can we tell according to the table? So at 350, we have 10 people, right? Now it says illustrate each. What does that mean? Like draw it, right? Okay. So at 350, we have 10 people. At 375, 375, we had 5 people. So following the pattern we've been talking about this whole time, at $4, 0. And that would be when no one would be willing to buy a snow cone. Okay? So what about a graph? How can we illustrate that? Well, what if we drew the graph, right? What's it look like? Like that? So where will no one be willing to buy a snow cone? At $4, where is that? The x-intercept right here, right? That would be $4 and 0. 0 people. Now what about the algebraic generalization? What does that mean? An equation. That's exactly right. Well, have we come up with an equation for this yet? No, then we better, right? I keep spelling algebra wrong today. That's really sad. So what is my algebraic generalization? What is my equation for this problem? Where did I start? When x was 0, what was y? 80. So I started at 80, and what happened? I decreased by 0.25x. Is that correct? Is that right? This would be okay if we had like 1 snow cone or 2 snow cones or 3 snow cones, but we don't, right? We have a price. And if I put in 0.25 right here, what's happening? 0.25 times 0.25, that's going to take us somewhere we don't want to go. It's minus something x, isn't it? So let's figure out what we need to put there. Any ideas? Well, we know that. Okay, so you want to do how much each x goes down and how much each y goes down? That's a good way to think of it. So how much does each x go decrease by? 5, So going from 70 to 75, that's a decrease of 5, right? So negative 5. But what about here, from 0.25 to 50? We're adding, so our difference is 0.25. So how do we find, and that's, we decided already that's common through the whole table, right? Okay, so to find our slope, we take our change in our y's over our change in our x's, right? What is our change in our y's? And what's our change in our x's? 0.25. So what is 5 divided by 0.25? You got your calculators? How many quarters in $5? Yeah, 20. Okay? So, and it's negative 20, isn't it? Okay? So, our equation then is 80 minus what? Minus 20x. Okay? So, how can I find out when my price, when my number of people would be 0? So when my y would be 0. Well, watch. 0 equals 80 minus 20x. How do I solve an equation like this? Subtract 80. Okay, we can subtract 80 from both sides, right? That's a 0. This is negative 80 equals negative 20x. And how do I solve for x? Divide both sides by negative 20. What's the answer supposed to be that we got from these two interpretations already? 4. Guess what negative 80 divided by negative 20 is? 4. Any questions?